The mysteries of the night sky. When you look up at the night sky, what do you see? A sea of tiny twinkling dots scattered across the darkness. But here's a question. Are all those stars the same? Do they shine with identical brilliance? Or is there more to the story? Today, we're diving into the secrets of stars. We'll explore what makes them similar, what sets them apart, and why understanding them reveals the incredible diversity of the universe. Ready to journey into the cosmos? Let's go. Stars, more than meets the eye. First, let's clear something up. From Earth, stars might seem alike. They're bright, they're far away, and they're countless. But this is just an illusion. Stars differ in ways that are nothing short of spectacular. Their size, temperature, color, and even lifespan vary dramatically. Some are so massive they defy imagination. Others are barely larger than planets. The first clue lies in their color. When you gaze at the stars, do you notice subtle differences? Some appear bluish. Others glow a warm orange or red. This isn't a trick of your eyes. It's a clue to their temperature. The colors of the cosmos' blue stars are scorching hot. Their surface temperatures can exceed 30,000 degrees Celsius. Red stars, on the other hand, are cooler, relatively speaking, with temperatures around 3,000 degrees Celsius. The color spectrum of stars tells us a lot about their nature, but temperature is just the beginning. What about size? From tiny dwarfs to colossal giants, let's start small. Some stars are dwarfs. The most famous example, the red dwarf. These stars are smaller than our sun and burn their fuel slowly. They can live for billions, even trillions of years. Then there are the giants. Stars like Betelgeuse, a red supergiant, are so large they could engulf entire solar systems. Betelgeuse, for instance, has a diameter over 700 times that of our sun. Imagine a star so big it could swallow Earth's orbit and still have room to spare. But the true extremes of star size lie in the realms of the smallest and the largest. Take neutron stars, for example. These are remnants of massive stars that have collapsed under their own gravity. A neutron star is only about 20 kilometers across, but contains more mass than the sun. A teaspoon of neutron star material would weigh billions of tons. On the other hand, hypergiants take size to the next level. The largest known star, UY Scuti, is over 1,700 times the diameter of the sun. If placed in our solar system, it would extend well beyond Jupiter's orbit. Life cycles of the stars and size affects more than just a star's appearance. It determines how a star lives and how it dies. Massive stars burn through their fuel quickly. They shine brightly, but live fast and die young. Their lifespans might be only a few million years. In their final moments, they explode as supernovae, scattering elements like gold and iron across the universe. Smaller stars, like our sun, have a different fate. They burn more slowly, living for billions of years. When they die, they don't explode. Instead, they shed their outer layers, creating beautiful nebulae and leaving behind dense cores called white dwarfs. What are stars made of? But wait, there's more. Stars also differ in composition. When the first stars formed billions of years ago, the universe was a simpler place. Hydrogen and helium were the main ingredients. Today, stars have a richer mix of elements. Thanks to generations of stars that lived and died before them, newer stars contain heavier elements like carbon, oxygen, and even iron. This chemical diversity shapes the planets and life forms that can emerge around these stars. Stars in the Milky Way. Now, let's zoom out a bit. How do stars fit into the Milky Way? Are they evenly spread out, or do they form patterns? Our galaxy is a bustling city of stars. It's home to over 100 billion of them. They're organized into groups, like stellar nurseries, clusters, and even rogue stars that wander alone. In stellar nurseries, new stars are born from vast clouds of gas and dust. Some of these stars stick together, forming clusters that orbit the galaxy's center. Others are more solitary, like our Sun. Clusters themselves come in different types. Open clusters, like the Pleiades, are loosely bound groups of young stars. Globular clusters, on the other hand, are densely packed, containing hundreds of thousands of ancient stars. These clusters orbit the galactic core and serve as time capsules of the early universe, the power source of stars. But even in their variety, stars share a common story. They're all powered by the same process, nuclear fusion. Deep in their cores, hydrogen atoms collide and fuse, forming helium and releasing energy. This is what makes stars shine. Fusion also creates heavier elements over time. In the heart of a massive star, elements like carbon, oxygen, and iron are forged. When the star dies, these elements are scattered into space, seeding the next generation of planets and even life. Think about that for a moment. The calcium in your bones and the iron in your blood were made in the heart of a star. We're literally made of stardust. The final act. Now, let's tackle one final mystery. What happens to stars after they've lived their lives? The answer depends on their mass. Smaller stars become white dwarfs, slowly cooling over billions of years. Larger stars might end their lives as neutron stars, incredibly dense objects where a sugar cube-sized amount of material weighs as much as a mountain. And the most massive stars? They collapse into black holes, regions of space where gravity is so strong not even light can escape. But black holes themselves come in different sizes. Stellar black holes are born from massive stars. Then there are supermassive black holes, millions or even billions of times more massive than the Sun, lurking at the centers of galaxies. Each of these outcomes contributes to the cosmic cycle. Stars are born, they live, they die, and they leave behind the building blocks for the next generation, a universe of unique stars. So, are all stars the same? Not at all. The next time you look up at the night sky, remember this. Each star is unique. Each one has its own story, its own journey, and its own role in the grand tapestry of the universe. And in understanding them, we understand a little more about where we come from and where we might be going. Thanks for watching. If you enjoyed this exploration, give this video a thumbs up. And don't forget to subscribe for more journeys into the wonders of space. Until next time, keep looking up.